This is Geometry Chapter 12. Everyone look on page 483. Look at the illusion of the circle. Everybody see that illusion? You see it? You see it. Okay, don't give it away. Don't give it away. Anybody else see the illusion? See something inside of it? You do? Yes? Who doesn't see? You don't see it? Okay, look at those circles. Like maybe tilt your book so that you see the reflection. Sarah, do you see it?
I see it now.
Am I dumb?
Oh wait, I see it.
I can see.
You saw it on
I
his.
saw when Dylan-
Yes.
I can see that there's something there, but I can't.
There is.
I only saw it
Never
with
shake your book. It looks better.
All right, can somebody tell me what it says? What will?
There's a two. Oh, okay.
You all see it?
It says E equal. Actually, I think it says E equals, and then below it, MC squared. Is that what it looks like? Yeah. That's energy equals mass. This is the speed of light. C is the speed of light. That is what it is. That's really like physics. You see E equals MC squared? Okay. So all of those circles on that one page have something in common. Can you tell me what they all have in common? Okay, I want everybody to look. Therese knows. Anybody else? They have something in common. All of those circles. Do y'all see it? Therese, what do they have in common?
They concentric. Maybe same like middle.
The same center. They have all the same center. So when circles have all the same center, we call them concentric. They are concentric circles. There's two things that must be true. They must lie in the same plane, and they must contain the same center. Okay? To be called concentric. So what is the definition of a circle? Look on page 44. This is an important definition, and it's a logical one if you think through it. I bet you've never thought, what is a circle? Well, here's what it is. It's the set of all points in a plane that are equidistant from a particular point in that plane. You always thought a circle was a line, right? But a circle is a collection of infinite points that are all equidistant from one point called the center.
I think we talked about this like right at the beginning of the year when we were going through definitions.
Right. But there's so many points that what appears is actually a line. Not a very good line, but a line. Actually, it's not a line. It's a curve. Right? Okay, there are an infinite number of points. When my graphing calculator graphs a line or a curve, you know what it graphs? Points. You know what it looks like to me? A line or a curve. But literally, that's what it's graphing, is all of those points. So a circle is all of the points that are equidistant from a given point in the plane. All right? Now, we know two things about a circle. What is that called? It's called a radius, or radii, right? For plural, right? And if I were to draw another radius here and another radius there and another one here and another one here, what would you know about all those radii? They'd all be the same. Every radii in a circle is equal. Look at that. That's on the page 45. So you can imagine we might just use that in a proof. All radii are equal. All of them.
That's how you spell radii?
Yeah.
Radii.
Yes. 2 eyes. I know, I'm not fond of the word. I much prefer radius. All right? So all radii are equal. All right, so now we're going to talk about a concept. If I have a segment drawn inside a circle such that the endpoints of that segment lie on the line, it is called a chord. By definition, a chord is a line segment drawn inside a circle whose endpoints lie on the circle itself. Now, there's a chord that you use all the time in a circle. And it happens to be the longest chord. What is it? Diameter. That's right. So when I have a chord that goes through the center of the circle, we call that a diameter. What's a diameter? A chord that goes through the center of the circle. It is the longest chord in any circle. Always the longest chord. A radii is not a chord. Why is a radii not a chord? Why are radii not chords? Since I'm talking plural. Yes, Hannah.
Is it because it goes through the center, it stops at the center?
Sort of. Yes, you're on the right track. Help her finish.
Because the endpoints don't touch different parts of the circle.
That's correct. Because its endpoints don't lie on the circle. You're right. It stops at the center, right? It doesn't go all the way through to the other side. Okay, so what do we know about the diameter? It's the longest chord. It always contains the center. And then there's something particular that we know about a chord. If I have a chord here, and then I draw a diameter through it that goes through the center, it will bisect that chord. It will bisect this chord as long as I know that this is perpendicular. If I know that the diameter is perpendicular to that line, then it bisects it, the chord. So if the diameter is perpendicular to a chord, then we can know it bisects the chord. Got it? Okay, so these are ACT worthy questions. I see these all the time. All right, let's walk through your theorems. Then we're going to do some homework. Look at Theorem 56. If a line through the center of a circle is perpendicular to a chord, it also bisects the chord. This is what I said right here. You know what? We can say the inverse of that. If a chord that goes through the center bisects the other chord, then what can we know? It's perpendicular, right? So if I just told you, if I told you that this chord, this long chord here, it contains the center and it bisects this other chord, then you can also know it is perpendicular. Do you see? It goes both ways. If perpendicular, then bisects. If bisects, then perpendicular. Got it? That's theorem 57. Okay, so there's a third way I can see this. If I know that this chord bisects this other chord and is perpendicular to it, then I can say that this one goes through the center, because that's the only chord that can bisect and is perpendicular to another chord. It has to go through the center. All right, so there's a couple things. If perpendicular, then it bisects. If it bisects, then it's perpendicular. Got it? If we know that that chord is bisected and is perpendicular to the other one, then we can say that this long chord is a diameter. It goes through the center. Does that make sense? All right.